The clock's already ticking, so I'm really condensing 1,800 minutes into a 20-minute talk. So let's get going. So thanks, Mike, for swapping slides or his positions, or I was really helping him, but thanks for the shout out yesterday. Aaron, thanks for lending me your charger yesterday. And so I'm Daniel Chen. I'm a PhD student at Virginia Tech. And the name of my program is in Genetics, Bioinformatics, and Computational Biology, which is under the Biocomplexity Institute of Virginia Tech. And I work in the Social and Decision Analytics lab, which is in Arlington. So my lab is 5 hours away from where I go to school. So that's also a little weird. And I also work with Jared. I teach. I do volunteer teaching for software carpentry. I maintain the programming with R lesson there. There's also another R lesson for R for reproducible scientific analysis. I've also taught for data carpentry. I co-teach the data science for public good program in my lab over the summer. And if you want to learn Git, there is a Pearson Git video of me rambling on the internet for many hours. Just a couple weeks ago, my data camp course, Cleaning Data in Python, was released, so thanks. And if you Google Pandas for Everyone, apparently, even though my book isn't even halfway done, you can find it on Amazon. So thanks for that. I also just bought a typewriter, so this is my new typewriter, and I think it's cool. So data science is becoming really accessible. If you guys haven't seen, this is a tweet by Mark Cuban, which is, even though it's a Python book, don't worry about it. And even though it's Jupyter, don't worry about it. But it is machine learning, and it is some high exec doing machine learning. And we heard the talk earlier, is machine learning just going to be automated and we're going to be out of a job? The answer is no. So what I plan to do in the next 18 minutes is teach you all this. So as you can see, this is slide 8 out of 57. So let's just go. So project templates. So how many of you guys, when you work on your projects, do you have project templates? Or do you just dump everything in the same folder and that's just how it works? Yeah, project templates, they're great. Gives you some kind of standard to work in things. It makes it easier to share and collaborate with other people just because they know where to find your stuff. And it's easy for yourself because you want to be able to know how to run your code or look where you put that piece of documentation minutes, hours, years from now. And so there's a paper in 2009 for those who are academics and you have to cite something. There's this paper by Noble on the quick guide to organizing computational biology projects. And he outlines what type of folder structure are good for biology. Jenny, Brian, and we sort of took whatever came out of that paper and we wrote packages for it so you can automatically generate these project templates. John Miles White also has a thing called project templates that you can get from CRAN or on GitHub as well. And none of these are always set in stone. You start from one place and you can adapt it to how you want. So this is what that Noble figure looks like. You have a project and you have a series of folders. So data goes in the data folder. Doc, you put your documentation there. SRC for any of the code that you write, and you have results. The one thing I like to say, things that go in a data folder, they will never change. And the only way you change your data is everything has to be done by a script that you put in the SRC folder. Intermediate data sets go out into results or some kind of output folder. So this way you can keep your data and at least that doesn't change. All right, so bash, or the shell. So now you have your folder structure. How do you run your code? That's why bash is important. There's this thing called a cloud, so how do you even get to your code is why bash is also important. And here's the list of really basic commands that everyone should be able to learn, or I should instill in you in the next 20 seconds. Most importantly, CD for changing the working directory. That's how you essentially double-click your way around. Launching an R script, you can say R script and then the name of your R script, and then whatever you wrote there, that's what will run. The initial takeaway is it's really important to know what a working directory is because your scripts, especially if you're loading data sets, it's really important. That's how you find the data set you're trying to load. So a lot of people, they dump everything in the same folder just because it's just easier because they can just say, hey, load this data set here and don't really understand how folders and file structures and all of that work. If I was actually teaching at a software carpentry workshop, this is not really the actual initial takeaway for bash. It's really that you learn that functions do one task and they do it well. So the other thing with bash, SSH. This is how you connect to the quote unquote cloud. And it's a command, you say SSH and then some IP address. For RStudio users, you use SSH and you use the -L flag, and you say 8787 because that's what RStudio runs on, and then the actual thing that RStudio runs on, and then where RStudio exists. So if you end up with like an AWS server and it's running RStudio server, this is essentially how you would connect to it once you get the IP address. And then SSH keys. So you run it by running the command SSH-keygen, and you get a whole bunch of stuff. Eventually, you get something in your .ssh folder, and you essentially cat out this file, the idrsa.pub, and it's really important you use the public version. And essentially, that's what you will copy around to web services when they ask you for your SSH key. And this prevents you from typing a password. All right, next. So that's all of Bash, R and R Markdown. OK, so why do you want to learn R? Do your analytics in a programming language. It makes it reproducible, especially like Sandy mentioned, if your data set updates, you get to run the same thing again. And hopefully, your analysis comes out the same, or your analysis comes out better, but updated. And you should be using it to directly manipulate your data, not go into Excel or open it up in a text file and change data values. What's also cool about R is you get to test your data. So you get to write little test cases to make sure your data is what you expect. And I talked about this last year. So installing R. If anyone's working in IT, just earmuff, because this is really how that slide really should read. One simple way is really if you can just write one ticket and get Anaconda installed, you'll get a lot of your problems solved because you have access to change what's in your local user, right? No, you're shaking your head, maybe. Works for me. Your model may vary. And then you run conda install R and R essentials, and then you have R all installed. So hopefully that's one tip that I can offer you. If not, I'm really sorry. R Markdown. So the Jupyter folks call it the last mile, or for Jupyter notebooks, of programming, where you've done all your analysis, now you're presenting something. And this type of interweaving output code and text is called literate programming. And this is how you can generate interactive reports or reports that can update themselves. Or you can use R Markdown to create dashboards, like Flex dashboards by the RStudio folks. And so this is what an R Markdown source thing looks like. You have some YAML header at the top that just specifies how the thing will get built. You have these things called R chunks that will run R code. And then this is regular Markdown stuff. And the output is some really nice, pretty formatted document. And this requires very little work on your part. You write your R code, you explain it, you click a button, and a report comes out. There's also this new thing called R Notebooks, which is very similar to Jupyter Notebooks, and it's very similar to R Markdown. The only real difference is, when you execute your R Markdown cells, whatever output comes out in line. So instead of in the console, or instead of rendering the entire document, it shows up underneath. And so, quick thing about Markdown, you have italics, bold, bullets, lists. The cool thing about lists is you don't actually have to have them in correct number. It'll render it out for you. So guys who type notes on your computer, Markdown is you're probably typing your notes like this anyway. So if you dive a little bit more into Markdown, you can actually render your documents as well. Rendering your Markdown documents, that little knit button on RStudio is actually running a command called render. So if you ever need to follow that folder structure thing that I talked about, you'll realize that there's certain really annoying things about that knitter button. So I'm trying to write an add-on package that will solve that. Essentially, if you click knit, it thinks that the working directory is where that file is, instead of where you put the RStudio project object. All right, R. OK, I think I'm doing pretty good. I'm more than halfway through. OK. So loading your data in R. There's the read Excel library for those who need to read in Excel sheets. There's Haven for if you need to read in Stata, SAS, or any other non-R programming language data set. There's the read R library by Hadley, which is a faster way to read in CSV files. And I guess I sometimes still use read.csv. I don't know how many of you guys still use read.csv, but that's there too. The main takeaways for R is really learn about the apply family of functions. That's probably if you were to spend an entire afternoon learning one thing about R, is learn how to write and apply. There's also these other tools that we've talked about or heard about throughout the entire conference, is the whole entire tidyverse of packages like tidyr, dplyr, and pure or purrr. And you can install it all under this tidyverse meta package. In the entire tidyverse world, there's, when you're done with your cleaning your data and you want to do your analysis, David Robinson wrote a package called Broom, and there's a talk about it from last year. Essentially, now that you have your data output, your analytics output, Broom sort of ties that all together in that like you have this table of betas from like a regression model or something, and it gives it back to you as a data frame, which is what you wanted anyway, instead of playing around with weird R lists. And then, again, I am a software and data carpentry instructor, so a lot of these things are also available there, and it's free, it's open, it's Creative Commons, and it's edited and taught by hundreds of people around the world, so I think it's a pretty good set of lessons if you want to learn something or anything. At the very least, learn one thing in R, save it out, and proceed with your usual pipeline. I'm not going to say Excel is bad or terrible and you should never use it. I started off that way. For example, the only thing when I was learning R was I would get data in essentially a one-dimensional vector, and essentially every 3 corresponded to like a data observation. So what I really just used R for was like this set, these 3 lines of code where I would read in a data set, just manipulate it into a matrix and write it out and then do the rest in Excel, just because that's all I knew. And then slowly over time you'll build, you're like, oh, maybe I want to do something else, like add a column or something. And then you'll slowly build on your skills one by one. All right, Git. I'm going to teach you guys Git in the next 8 minutes or so. So this is the problem Git solves. We all have had this problem where the final doc is not really a final doc. If you look at the commits in this presentation, there's final 2 question mark. So Git just allows you, it's really Control S or saving documents on steroids. And it allows you to tag each type of save that you do, so you don't have to write, your file name doesn't have to say final rev2. The commit can just say final rev2. It makes it a little easier so you're not staring at a folder with 50 million files. The quick thing about Git, always, the way I like to do it is I make a Git folder in my home directories, and then I throw all my Git repositories in there, so this way I don't accidentally forget what is or is not a Git track project. Git init will turn it into whatever folder into a repository. For people who are new to Git, just don't type this in any other subfolder beyond that. You can do it. It's not going to yell at you. You might hate yourself later. And then the entire process of saving in Git uses add and commit. So you add a file to a staging area, and you commit a message. And after that, you've essentially done the on steroids version of Control S. So this last thing, if you're just starting out with Git, just do this last thing over and over again every time you are changing. Even if you're working on like a Word doc or something, just do that and just get in the habit of doing that, and you'll be less afraid to learn the next thing. So need more backups, remotes. This is sort of where GitHub comes in. So a remote is really any place that's not where you type git init. A lot of people like to use GitHub as a remote, but it could be another server that you own or another folder or place on your computer. And essentially the way you save and communicate with remotes is you push to a remote and you pull back code from a remote. And these words origin and master, origin is really just a convention for the first remote that you have. And master is really the convention for the name of commits or the saves that you are making. So creating a remote, you can go to GitHub, you can click the green button on the page. There's various ways of getting there, and they're typically green. I would say create your remote on GitHub, pull down your code, and then start your project from there. It makes life a little bit easier. And then you'll see this page after you click that button, and you get to say, rename your project, add a description. I totally spelled amazing wrong, yeah. But the thing I want to point out on this page is always add a license, because so if you're already on GitHub, it's already public. People want to be able, if they stumble across this, they want to know like what can they do with this. Especially if you're working with librarians or stuff, people in libraries love licenses just because it specifies what you can do. And if you really don't care, just pick the MIT license. It essentially just says, I don't care, just credit it back to me. Adding git remote, so you have to point git to where your remote is. And in every GitHub repository, you'll see this clone or download button. You saw that in the previous talk, I think. And you specify that link right there. That's how you get that git remote link. All right, empty folders in Git. So Git actually doesn't track empty folders. So if you create some folder in your project template, like output, that you know that will always change and nothing in there should be saved, the trick is to put a .git keep file there and track that. And then so this way, when other people download your project, they at least have that output folder, even though it's empty. All right, SQL. Stands for Structured Query Language. They're used to interface with databases. And they're useful if data can't be CSV'd and passed around or if it's too big for memory. So R and SQL, there's a lot of, what is it? The other database thing that's really popular that I can't think of right now. SQLite. But here's an example in Postgres, just because there's enough SQLite examples out there. So there's an R PostgreSQL library. You can create a driver, and then you give that driver a connection by passing in the database you want to connect to and the username and password. And then you can build a regular SQL query. So I want to select everything from the MyTable column. So you can build an SQL query. I like to use the sprintf command just because it's a little nicer to the eyes than using paste to build in queries, especially if you have like variables, R variables that you want to throw around in creating this string. And then to run it, so this is the exact same code as before, but to run it, in R PostgreSQL and a lot of the R database name SQL libraries, you run the db-get query, you give it the connection to the database and a query, and what you get back is the data frame that was selected out. We can do this all in dplyr as well. So here's group by an average of some diamonds data set from dplyr. This is how you would do it in dplyr. But we can use dplyr with SQL as well. So instead of the R data frame object, just give it the database or the table connection from your database connection, and all your dplyr code, it will be exactly the same. All right, last thing, make. So what is make? It allows you to assign dependencies in source code. So instead of at the top of each R file, you're saying source this file, et cetera, et cetera, et cetera. It only executes commands that are deemed out of date. And out of date is termed by, it's dependent on the last time you've opened a file, so by the timestamp. So here's an example of a makefile. So following John Miles White's R script naming conventions, I have a file named 01 make data. So this is where all of that data cleaning stuff is going on. So I load up my libraries. I have my diamonds data set. I'm grouping by the cut of diamond and getting the average carat for each cut. Right? So I save that to a data frame. And then I write that data frame out. So because it's not an ephemeral data set, I put it in the output folder because I don't really care what's in the output folder. Everything in there is not original data. So the second file I would have would be the actual analysis plot, or in this case, just making a plot. And so I have my code. I reload in the files the libraries I want. I read in my data set, and I write my output file. Right? So this is some general example of what you would be doing with your data, with your analysis. So the actual make file, you specify that you have a dependency CSV file. This is what creates that. And in here, in a new line, and the beginning of that new line has to be a tab because make was written by an intern at Bell Labs over a weekend. So don't trust your interns, I guess. But it's prolific. So this is the command that's required to create this thing. So how do I create the CSV file? How do I create the image? Here is just a command just to delete everything and start over. And instead of specifying this all the time, I just say, hey, I want to create my plots. You can either say, I want to create the analysis for analysis 1, analysis 2. So there's different ways you can create analyses, and this is how you specify the scripts required to run that analyses. And then you make it. So I call make plots, and everything, all the dependencies that it requires, it'll run. And so this is the output from R. even though I ran it in bash. And then if you make it again, you'll see that nothing is to be done because all the plots are up to date. And so looking forward, I want to turn these 57 slides into a data science class, which universities are sort of gearing towards. And this is all the tools that you need to be a scientific data analyst. So thanks.